Electronic circuits, operational amplifiers in linear circuits. Hello everyone, my name is Rafael. I'm an electrical engineer, and in this video I'd like to show to you an example of operational amplifiers in linear circuits, and to do so I chose this problem here. The objective is to find I and V3 with respect to V2 and V1, and to do so we are going to break the circuit apart. We can use the linearity of the problem to break the circuit apart. We are going to find a solution for this part first, and then we are going to find a solution for this part here, and then we are going to find what the problem wants us to find. See that we can do this, the operational amplifier connected in the non-inverting configuration here, okay, non-inverting terminal, and then I have the feedback loop around the operational amplifier, and here the input signal V1, and here the ground. Okay, what we want is to calculate V1 prime first. Okay, if we use the theory of operational amplifiers, we're going to see that V1 prime is equal to 1 plus R2 divided by R1 times the input signal V1. Okay, so this is what we are going to use. And since the problem said that the values of the resistances are all 1, then we find that V1 prime is equal to 1 plus 1 times V1, and V1 prime is then equal to 2 times V1. Okay, very easy, isn't it? Did you guys like it? So let's save these values here. V1 prime equal to 2 times V1, and then we are going to move ahead to the next part of this problem here. Okay, the next part of this problem will be to find the current I, because we already know the value of V3. V3 is actually V3, we already found V3 is actually V1 prime equal to 2 times V1. Okay, we already found V3 here. Now what we need to do is to find the value of the current. Okay, and the value of the current is going to be equal to, we are going to find this right now. Okay, cool. Alright, we want V3 here on top of R5, and here I have R3 and R4 here, R4 and R6. Okay, and the current that we wish to find is this, V1 prime, and here V2. Okay, we are going to use Kcl theory here to calculate the node currents. Alright, I'm going to call here Vk just to help us calculate, and here I'm going to call V3. And the current can be written as I equal to, as the current is going this direction, we can say that it is V3 minus Vk divided by the impedance, the resistance R3. Alright, so this is the value of the current. But we don't yet know Vk. We need to work on this value to find I. And we're going to do this. We're going to find a value for Vk. Vk, we can use this current here, we can use this current here, and we can use this current here. And then we're going to find that V2 minus Vk divided by R4. This current that enters here is V2 minus Vk divided by R4, and then this current that goes down here is Vk divided by R6 plus this current that goes in this direction is the opposite of I. Then it is Vk minus V3 divided by R3, okay? Then what we need is to work on this expression here. I already did that, and I'm gonna use my solution to cut some time here, okay, because we want to make this video quick. And you can simply rearrange this. If you do that, I can guarantee you're going to find the value. You can rearrange this, and then you're going to find that V2 divided by R4 plus V3 divided by R3 is going to be equal to Vk times 1 over R4 plus 1 over R6 plus 1 over R3, okay? And then you solve this, okay? And by multiplying and finding the least common denominator here, you're going to find the solution. And then, as the problem says that all the impedances are equal to 1, all the resistances are equal to 1, we can find that Vk is equal to V2 plus V3 divided by 3, okay? This is what we're going to use to calculate everything. Alright, we are going to substitute this there, and we're going to find that I is equal to V3 divided by R3 minus Vk divided by R3, which is equal to V3 divided by R3 minus 1 over R3 V2 plus V3 divided by 3. Okay? We simply use this value here. We substituted this here, okay? Follow the arrow, this here, and then we got this, okay? Do you guys fully comprehend what I did? And then, after doing some algebraic manipulations, we are going to find that the values are of the sort, okay, I is going to be equal to 2 times V3 minus V2 divided by 3, okay? So this is the current. This is what we wish to calculate, okay, my friends? I took this problem from the entrance exam of the Federal Police of Brazil, expert in electronics. And then I just wanted you to see how it is like to calculate for linear circuits when there is an operational amplifier present in the circuit. And then what we need to do is to simply use these other details here. For example, we found already that V3 is equal to 2 times V1. Okay, we already know this. Alright, and then what we need to do is to put this here. So I is going to be equal to 2 times V1 minus V2 divided by 3. And then we have successfully found the answer. 4 times V1 minus V2 divided by 3. Okay, these are the answers of the problem. We have successfully written V3 and I with respect to V2 and Vi, my friends. Okay, this was the video that I wanted to make. I hope you guys enjoyed it. I am a teacher. If you want to book a lesson with me, use my WhatsApp number. Goodbye!